Welcome to this custom deep dive. Today we're cutting through a stack of highly dense papers on zero-point energy and a theoretical framework called curvature variable physics, or CVP.
Yeah, there is a ton to get through today.
There really is. And we know you already follow the theoretical physics space, so we're skipping the basic primers and getting straight to the mechanics. Okay, let's unpack this. We all know the quantum vacuum is, well, it's boiling with baseline energy, but the ongoing frustration has always been actually accessing it.
Right. The absolute roadblock is the second law of thermodynamics. The vacuum sits at a strict thermal equilibrium and, without a gradient, you're locked out.
It's just a flat line.
Exactly. I mean, decades of attempts, mechanical Casimir engines trying to compress zero-point forces, or those aggressive vacuum decay models using intense magnetic fields, they all hit the exact same wall. You simply can't cheat the thermodynamic reality check.
Which is exactly why the historical pursuit usually gets tossed into the fringe pile. But here's where it gets really interesting. I was looking through the notes on Timothy J. Dillon's industrial research, and he introduces this CVP framework that essentially changes the rules of the game rather than trying to cheat them. How does the math actually bypass that equilibrium bottleneck?
What's fascinating here is how CVP fundamentally breaks a century-old relativistic assumption. It tosses out the idea of the speed of light as a rigid universal constant.
Right, the speed of light becomes variable.
Yes, via the Dillon operator. Dillon introduces this operator, which dictates that light speed directly fluctuates based on local spacetime curvature, by mathematically treating geometry as an active, bendable variable.
Rather than just a passive backdrop.
Exactly. You aren't fighting the vacuum's thermal equilibrium anymore. You are altering the geometric rules that define it.
But modifying equations on paper is one thing. How does the Dillon operator translate into real-world wattage? Because if we can locally bend geometry, how do we get electrons to actually move?
That brings us to the first mechanism, which is the curvature-enhanced photoelectric effect. We know standard photoelectric emission requires high-energy photons to kick electrons loose.
Right, like standard UV light.
Yes. But if you artificially bend the local geometry using specific nanomaterials, you dramatically lower that threshold. Suddenly, incredibly low-energy infrared light, or even ambient heat, forces the material to emit electrons.
Hold on. So we're talking about solar panels generating power in the pitch black of night, or IoT sensors running indefinitely without a battery swap, just feeding off ambient thermal radiation.
Exactly. And that's just the microscale application.
Okay, so if that's the micro, what's the macro? How do you scale a geometric bend into grid-level power?
You harvest space-time tides, not ocean tides, but literal background geometric fluctuations. Earth is constantly undergoing massive geophysical shifts.
Like seismic activity.
Seismic activity, deep mantle convection, volcanic rumbles. These events subtly alter local gravitational potentials, creating continuous ripples or tides in the scalar curvature of space. Dillon proposes using a curvature vector engine.
A curvature vector engine.
Right. It acts as a highly tuned resonator to capture the physical strain of those fluctuations and pump it directly into an electromagnetic field.
A machine that converts the ambient rumbling of Earth's geometry into electricity. I have to admit, that sounds dangerously close to those perpetual motion scams you see online. How do we know a curvature vector engine isn't just an over-engineered antenna picking up stray Wi-Fi signals?
It's a highly necessary skepticism. If we connect this to the bigger picture, claims this paradigm shifting require absolute, unassailable proof. That's why the research mandates Tier 3 calibrated energy accounting.
Which means total isolation.
Pure isolation. To prove it is harvesting actual space-time geometry, the system has to operate inside total Faraday shielding to block all ambient electromagnetic radiation. Furthermore, it requires aggressive thermal soaks to ensure no subtle temperature gradients are skewing the data. The energy output has to survive absolute clinical isolation.
So what does this all mean for you? If this Tier 3 validation holds water, we're looking past the era of massive lithium mines and intermittent wind farms. We're looking at a civilization powered by a lossless grid, running entirely off the continuous geodesic strain of the planet itself, the ultimate end to battery anxiety.
It completely redefines our engineering limits, and this raises an important question to leave you with. If we master harnessing Earth's specific geophysical mass fluctuations, what happens when we deploy these curvature engines for deep space colonization?
Oh, that's a wild thought.
How will a machine calibrated to Earth's geometric tide function in the radically different, quieter gravitational environments of the Moon or Mars?